In this video, so I'm going to explain different types of frequency demodulators. What is this frequency demodulator? A circuit that recovers the original modulating signal from an FM transmitted signal are called demodulator or detectors. For example, in this case, this is the carrier wave and this will be the message signal, and this is the modulated signal here. In this case, we have taken a simple sinusoidal message signal. With respect to the variation of this signal, variation of the amplitude of this signal, FM is varied. So this is the signal arrived at the demodulator. Demodulator has to recover this message signal or modulated signal. Yeah. So a circuit that recovers the original modulating signal from an FM transmission are called demodulators or detectors. There are different types of detector. So broadly we can classify as slope detector, pulse averaging discriminator, quadrature detector, PL. So I'm going to discuss these two demodulate. First we will see how this slope detector will detect the transmitted original message signal. This is the message signal we have to retrieve back from this slope detector. And this is the circuit about the slope detector. This one is the slope detector. Primary of the transformer T1, L1, and this is the L2. And received signal, that is FM modulated signal, is given to this primary of the transformer L1, and that will be appeared in the secondary of the transformer L2. T1 is a transformer, L1 is the primary, L2 is the secondary. C1 is the capacitor connected across this L2. D1 is the diode. In this case, it is used as a rectifier. And this is the R1 and C2, and this is the bypass capacitor. And similarly, this L2 and C1 acts as a circuit, filter circuit. Okay, it acts as a filter circuit. So this is the response of the this filter on L2 and C1. This what that acts is voltage across C1. As this frequency go on increasing, the response is like this. At resonant frequency, means when the circuit is resonance, L2 and C1, we are getting the highest output. And this center is the carrier frequency, that is FC. This point is FC. Above this point we have, and above below this. These are means lower frequency produces a lower voltage. Higher frequency produces a higher voltage. Means this is the carrier frequency. At the modulator, carrier frequency is varied, increased or decreased. So in this case, increase or decrease. Okay, so and how this circuit works as a demodulator, we will see. The circuit uses a tuned circuit. This L2 and C1 is a under diode detector to convert the frequency variation to a voltage. The FM signal is applied to this primary of the L1, and the transformer secondary L2, and the C1 forms a resonant circuit. Means the circuit is going to be resonant. At this resonant frequency, it has a highest output. At lower or higher frequencies, the voltage decreases. The circuit means this is tuned for a carrier frequency. If the frequency lower than the carrier frequency, this is the carrier, this is the FC. Lower than this, it go on decreasing. Voltage across this C1 is decreased. Above this, it go on increasing. If the frequency goes lower than the carrier frequency, output voltage decreases. If the frequency higher, it go on increasing here, increasing, then the output, it is higher. Thus AC voltage across C1 is proportional to the frequency. Means this output, you look at this, as we go on increasing, it is increasing, decreasing, decreasing. This is the how the actually we made the modulator. The voltage across C1 means this one is rectified, and this is the diode is D1 rectified into DC and passes through the across the load R1, and this is the bypass filter. Okay, through this output will be taken. The voltage across C1 is rectified into DC pulses. These pulses are filtered into a varying DC signal. So in this way, this acts as a slope detector, acts as an FM demodulator.